Students, the video which I am going to present you will contain the entire explanation of the chapter, and these are in digital formats. Keep on repeating these videos, okay, to get the clarity in the explanation, and make sure that you pay full attention when you plug in the pen drive, okay. Or if you are watching in the phone, then make sure that you keep your headphones so that you can keep yourself away from the distractions at home. Okay, do watch this video and try to save this video, and at least make sure that whenever you start this chapter is matter around us pure, see these videos once. The next, after 2-3 days, my explanation is going to continue from where I have stopped.
Hello there. We have already studied about the classification of matter based on physical properties in our previous video. So what comes next? Now we are going to classify the matter based on chemical properties and also study about the different types of separation of impure matter. So first of all we will classify the matter, and after that we will know in detail about those classified substances. And lastly, we will know about the ways of separation and their applications. Let's start the chapter with the classification based on chemical properties first. Well, according to chemical properties, the matter is classified into two types. They are pure substances and mixture. Now, pure substances is classified into two types, which are elements and compounds. Also, the mixture is classified into two types. They are heterogeneous mixture and homogeneous mixture. We are going to start chapter with describing mixture and its types. So basically, what is mixture? A mixture is the combination of two or more substances combined in any proportion. Also note that substances in mixture do not chemically combine together to form a new substance. Therefore, a mixture can be separated using physical method. Now, what are the examples of mixture? And they are lemonade, coke, stones in rice, air, etc. We already know that mixture is of two types. So, what is homogeneous mixture? A mixture is said to be homogeneous if all the components of the mixture are uniformly mixed and the composition is uniform throughout the mixture. Examples are sugar in water, cold drinks, etc. Now, we knew about homogeneous mixture. So, we are going to define heterogeneous mixture. A mixture is said to be heterogeneous if all the compounds of the mixture are not uniformly mixed and the composition is not uniform throughout the mixture. Examples are water and sand, air, etc. But again, one question is still in our mind, that how we will distinguish them when we will see them. Well, the components in homogeneous mixture can't be seen existing separately. The component will be seen equally divided in all the layers of the mixture. There will be no variation. This will be not the case in heterogeneous mixture. The mixed substances can be observed, and also they are not uniform in whole mixture. There are few types of mixture we need to know. They are solutions, colloids, and suspensions. Well, these type of mixture will fall under the category of either homogeneous mixture or heterogeneous mixture. So, let's start with the solution first. A solution is a homogeneous mixture with tiny particles having two or more substances mixed together. The particles are too small to see and also too small to settle or be filtered out of the mixture. Also, a solution has two components. They are solute and solvent. What are these? The component of the solution that dissolve the other component in it is called the solvent. Usually, solvent is present in larger amount. And what is solute? The component of the solution that is dissolved in the solvent is called the solute. Usually, solute are present in lesser quantity. Examples of solution are salt dissolved in water, ink, etc. Now, we are going to discuss some properties of solution. The particles of a solution are smaller than 1 nanometer in diameter, which cannot be seen by naked eyes. The particles or the solute present in the solution do not settle down at the bottom of the container when left undisturbed. They do not scatter a beam of light passing through the solution, which means they don't show Tyndall effect. The solute particles can't be separated from the mixture by the process of filtration. We also need to calculate the concentration of a solution. But before that, we will know that concentration of solution is. The concentration of a solution is the amount of solute present in a given amount of solution. Also, the amount of solute dissolved in given mass or volume of solvent is called concentration of solution. On the basis of concentration of a solution, it is divided into two parts, which are saturated solution and unsaturated solution. We will define both of them. Saturated solution. When no more amount of solute can be dissolved in a solution at a given temperature, it is called a saturated solution. Unsaturated solution. When more amount of solute can be dissolved in a solution at a given temperature, it is called a saturated solution. One more thing we need to define, which is solubility. It is amount of the solute present in the saturated solution at the given temperature. Now, we will know how to calculate concentration of solution. There are two methods to calculate concentration of solution. It can be calculated by dividing amount of solute by amount of solvent, or by dividing amount of solute by amount of solution. Here, amount means mass or volume. Two methods of finding concentration of solution are: first is mass by mass percentage of a solution, where we will divide mass of solute by mass of solution and then after multiply it by 100. And second is mass by volume percentage of a solution, where we will divide mass of solute by volume of solution and then multiply the result with 100. Now, we are going to learn about colloids. How can we describe it? Well, a colloid is a heterogeneous mixture with medium-sized particles. It appears to be homogeneous mixture, but it is heterogeneous mixture. The particles are large enough to see, but not large enough to settle or be filtered out of the mixture. Examples of colloids are fog, cloud, shaving cream, etc. We are going to discuss some properties of colloids now. Colloidal particle can easily be scatter a beam of visible light. This phenomenon is called Tyndall effect. The particles of colloid can't be seen by naked eyes individually. It is a heterogeneous mixture, but solute and solvent can't be separated by filter paper. Size of particles is between 1 nanometer to 100 nanometer. It is a stable mixture. Particles do not settle down at the bottom over a period of time. They do not settle down when left undisturbed, which means colloid is quite stable. For a colloid to be present, it has two medium which are dispersed phase and other one dispersed medium. These two medium can be solid, liquid or gas. Some common examples of colloid with dispersed phase and dispersed medium are shown in table. And our last topic in mixture is suspension. What is suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Examples of suspensions are chalk in water, smoke in the air, etc. Properties of suspension are: it is a heterogeneous mixture. Particles of a suspension are visible to the naked eye. Size of the particles is greater than 1 nanometer. It is unstable mixture. Solutes settle down at the bottom over period of time. If the solution is passed through filter paper, solute and solvent get separated. It scatters light. When light is passed through the solution, it shows Tyndall effect. Now we are going to discuss about physical and chemical changes, and also we are going to distinguish between them. First, we will know what is physical change. The process which brings about changes in physical properties and no new substances are formed are physical changes. The common physical changes are changes in color, hardness, rigidity, fluidity, density, melting point, and boiling point. Now we are going to describe chemical change. The process in which new substances are formed and chemical properties of substances get changed are called chemical changes. Some chemical properties are odor, inflammability, etc. Difference between physical and chemical changes are: physical change bring about change in physical properties such as physical state, shape, size, etc. while chemical change bring about changes in chemical properties like odor, new substance formation, etc. In physical change, no change in chemical composition are observed, while in chemical change, changes in chemical properties are observed. Physical change is reversible process, while chemical change is irreversible. That means it is permanent. No new substances is formed in physical change, while there is formation of new substances in chemical change. Lastly, we will know about pure substance. We already know that pure substance is categorized into two parts on the basis of their chemical composition, which are elements and compounds. So, first of all, we will know what is an element. Well, element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Means, it is the simplest form of matter, contains only one type of particle. Examples are hydrogen, oxygen, iron, etc. Further, element is divided into three types, which are metals, non-metals, and metalloids. We will learn about them, but before that, we will define compound. So, what is a compound? A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Here, we used fixed means the elements will always combine with each other to form compound in a fixed ratio. Example is water, which is formed by mixing of two elements that are hydrogen and oxygen. They combine in the ratio of 2:1 to form water. Now, we will know about the properties of metal, non-metal and metalloids. We already know that they are elements. Properties of metal. They have a luster, which means they are shining in nature. They have silvery grey or golden yellow color. They are ductile, means they can be drawn into wires. They are malleable, which means that they can be hammered into thin sheets. They are sonorous, which means they make a ringing sound when heated. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Properties of nonmetals. They display a variety of colors. They are poor conductor of heat and electricity. They are not lustrous, sonorous or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, chlorine, etc. Lastly, the metalloids, elements having intermediate properties between those of metals and non-metals, are called metalloids. Examples are boron, silicon, germanium, etc. Now we will differentiate between mixture and compounds. Talking about mixture. Elements are compound just mixed together to form a mixture and no new compound is formed, while elements react to form new compounds. A mixture has a variable composition, but the composition of each new substance is always fixed in case of compound. A mixture shows the properties of the constituent substances, while in compounds, the new substances has totally different properties. The constituents of mixture can be separated easily by physical methods, while the constituents of compound can be separated only by chemical or electrochemical reactions. That's all in this chapter. We still need to know some physical method for separation of mixture that we will cover in next video. Thank you. Hi again. We have already discussed about the classification of matter on the basis of chemical properties. Now, in this video, we will know the ways to separate the components of mixture. Well, different methods of separation are used to get individual components from mixture. Heterogeneous mixture can be separated into their respective constituents by simple physical methods like hand picking, sieving, filtration, etc. But in this video, we will learn about some complex physical method used for separation of mixture. First of all, we will study about filtration, then after centrifugation, separating funnel, sublimation, chromatography, distillation, fractional distillation, and crystallization. We will also learn the application and steps to do this process. So, let's start with evaporation. The process of evaporation is used to separate a substance which is dissolved in water. We will see this process by obtaining colored components from blue, black ink. Well, process of evaporation is used to obtain colored component from blue, black ink. This process is based on the fact that liquid vaporizes easily than solid. It helps in separating volatile substances from non-volatile substances. Now, we will see the steps involved in obtaining colored component from blue-black ink. First of all, a beaker is half filled with water. Then after, a watch glass is put on the mouth of that beaker. Few drops of ink are put on the watch glass. Now, we will start heating the beaker. We added water because we don't want to heat the ink directly. We will see that evaporation is taking place from the watch glass. We will continue heating as the evaporation goes on and stop heating when not any further change on the watch glass is observed. The colored components of ink left behind in the beaker. In this way, we will obtain the colored components by the process of evaporation. Now, the second process we have to study is centrifugation. This process is used in separating the suspended particles of substance from a liquid. It also helps in separating the cream from milk. This process is carried out by the machine called centrifuge. But why we use centrifugation to separate suspended particles instead of filtration? Well, sometimes the solid particles in a liquid are very small and pass through a filter paper. For such particles, the filtration technique can't be used. The basic principle involved in centrifugation is that the denser particles are forced to the bottom and the liquid being lighter remains at the top. So, this process is based on densities of the components which are mixed thoroughly. The mixture is rotated rapidly so that the heavier particles in the mixtures settle down to the bottom. To understand it properly, let's see steps involved in separating cream from milk. First, we will take some full cream milk in a test tube. Now, we will centrifuge it by using a centrifuging machine for 2 minutes. What we will observe after that is milk is settled at the bottom of the test tube and cream being lighter than the liquid is present at the top of the test tube. In this way, we separated the cream and milk by the process of centrifugation. Now, we will see some application of centrifugation. This process is used in diagnostic laboratories for blood and urine tests. It is also used in dairies and home to separate butter from cream. Also in washing machines, it is used to squeeze out water from wet clothes. Next, we will use separating funnel to separate the mixture. Well, funnel is used in separating two immiscible liquid. The basic principle involved is the difference between the densities of two liquid form two separate layers. We will understand the use of funnel properly by separating kerosene oil and water. So, let's see the steps. First, we will pour the mixture of kerosene oil and water in a separating funnel. After that, this mixture will left undisturbed for some time so that separate layer of oil and water are formed. Now, we will open the stopcock of the separating funnel and pour out the lower layer of water carefully. We will close the stopcock of the separating funnel as soon as the oil reaches the stopcock. What we observed? Well, we observed that kerosene is less in density than the water. Therefore, it will be at the upper layer of the funnel. So finally, we separated the water and kerosene oil using separating funnel. Let's see some application of funnel. It is used to separate mixture of oil and water. Also used in the extraction of iron from its ore. The lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. Now, we will discuss about sublimation process. First, we will know what is sublimation. Well, sublimation is process where a substance directly changes from solid to gaseous state on heating. Some examples of the compounds which show the property of sublimation are ammonium chloride, camphor, naphthalene and anthracene. This process is used to separate mixtures that contain a sublimable volatile component from a non-sublimable impurity. The next process which we have to study is chromatography. It is a physical method of separation which distribute the components between two phases. One is stationary and the other one is moving in a definite direction for the separation. This process is used to separate those solute which dissolved in the same solvent, like it is used for separation of colors. The colors which are more soluble in water rises faster on the strip and color gets separated into layers. Applications of chromatography are: it is used to separate colors in a dye. Also used for separation of pigment from natural color. It is also used to separate drug from blood. Now we are going to study about distillation. It is used for the separation of components of a mixture containing two miscible liquid that boil without decomposition and have sufficient difference in their boiling points. Mixture of acetone and water is separated by this method. The next topic is fractional distillation. It is used to separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 K. Air is a homogeneous mixture and can be separated into its components by fractional distillation. Below is diagram which shows the steps of separation of air. We will learn this in detail, that how we separate the components of air. First, the air is compressed by increasing the pressure and is then cooled by decreasing the temperature to get liquid air. The liquid air is warmed up slowly in a fractional distillation column, where gases get separated at different heights depending upon their boiling points. This process is used to separate a gas from the air. In the table, we can see the boiling point of oxygen, argon and nitrogen gas, and also the percentage amount of volume of these gases in the atmosphere. Now we will talk about crystallization. This process is used to remove impurities from solid and purify it. It separates a pure solid from mixture in the form of crystal. Applications of crystallization. It is used in purification of salt from seawater, separation of crystals of alum from impure samples. Now, evaporation is also used to separate impurities from solid. Then why we use crystallization? Well, crystallization is better method than evaporation. It is because solids decompose on evaporation, like sugar. It may get charred on heating and then to dryness. Also, some impurities may remain dissolved in the solution even after filtration, and on evaporation, these impurities can contaminate the solid. Thus, we prefer crystallization than evaporation. That's all for this chapter. We have studied the process to separate the impurities from mixture. Thank you.